Hello! In this video, I'm going to be going over one of my old designs for the VR shoe, which uses this part. If you're new here, I am trying to make a motorized shoe to be used in virtual reality games. The motorized shoe will keep you in the same spot in the real world while allowing you to walk so that you can walk infinitely in the virtual world. If you want to see my build log for the current design that I'm using, I'll leave a link to that in the description. So, here's the main part of the old design. Here is the same part, a little bigger. It relies on bevel gears. You can see, here's a couple bevel gears. This one drives the wheel. This is the one that will, this bigger one is spun by the motor. See? But here, if I just hold it like this, you can see the two gears, they are not touching. So if this turns, it doesn't drive the wheel. What happens is when it's like this, when the top gear, the bigger gear turns, everything turns. It reorients the wheel in a different direction. But if you push these together, then when the top gear turns, it'll turn the wheel. With that in mind, we have the same thing here. So when the motor turns, it'll turn it'll reorient the wheel, the direction of it. But then if I push this down, the direction of the wheel is locked in place, and the two gears are pushed together. So then when this gear turns, it turns the wheel. So the way that works is when the user brings their foot up to take a step forward, the motor would turn the wheel in the direction that it needs to. So if the user is going straight forward, then like the user is going this way, then it would orient the wheel in that direction. But if the user is strafing or going at an angle, then it would turn the wheel in the appropriate direction, like so. Then when the user finally brings their foot down in front of them, this is where their foot would be. They would push everything down, and then that would lock these two gears together, and then, when the motor turns, it would actually turn the wheel to bring the user back. So let's see, there we go. And then the user lifts their foot up again, goes in another direction, wheel reorients itself, user brings their foot down, and then same thing happens. If you're wondering how is this middle part locked in a certain direction when based on when the user puts their foot down, based on that, I'll explain that in a minute. But that's the basics of how this works. So essentially, the advantage of this is one motor can control both reorienting the wheel in a different direction, and then also driving the smaller wheel in here as well. It can do both of them depending on if the user's foot is up in the air or on the shoe. Okay, so here's this component. I'm going to explain how the wheel is locked in its current orientation when this whole thing is pushed up. So if I get rid of the turntable here, you can see that there's two sets of teeth. This top set does not move at all. It's attached to the frame itself. So here's the panel. This panel doesn't move, and the teeth are attached to it. So this top layer doesn't move at all. The bottom layer of teeth, it can move. As you can saw, that this whole thing can turn. But then when this thing is pushed up, these teeth will mesh, and it'll resist this whole thing turning at all. So when the user puts their foot down and presses the wheel into the ground and pushes this up a bit, these two sets of teeth will mesh, and the wheel will not be able to change its orientation, its direction that it's going in. Okay, so that's how that works. But when the user's foot is not on the shoe, so this thing is hanging, and these two sets of teeth are not meshed, there's another set of two teeth that are meshed right here. So this set of teeth is attached to the large bevel gear, and then there's a set of teeth here, as you can see, that are meshing with them. So with those two teeth meshed, when this bevel gear turns, this middle part will turn with it. And the teeth are only meshed when this shoe, or not, sorry, this wheel is not being pushed up. When it's pushed up, the teeth around here are not meshed, and the teeth here are meshed. When the shoe is not pushed up, these teeth are not meshed, but these teeth are. So you can see how when the wheel's not pushed up, it'll turn along with this bevel gear, but when it is pushed up, it'll not turn. This whole thing will not turn, and the wheel will stay in the same direction, whatever direction it is at that time. And then again, when the wheel is pushed up, this gear and this gear mesh too, so that when this big bevel gear turns, the wheel will turn. Okay, that's pretty much it for how this thing works, depending on if the wheel is pushed up or is not pushed up. The main reason I didn't go with this design is because it's complex. There's a lot of parts in here that could break. There's a lot of things that need to go right for this design to work. When the user pushes their foot down into the shoe, all that weight has to transfer evenly over to here so that these two teeth come in contact and remain in contact. I had problems where I would put my foot down over here, but the plastic would just kind of bend up over here. It wouldn't directly transfer it over. So I tried using like metal rods and brackets to help with that, and that kind of worked, but it increased the complexity. So sometimes these teeth would skip, and then the teeth that are locking the thing into its orientation when you're pushed down, I was worried that those would get worn out over time. I actually already saw them getting worn out a little bit as I did my testing. And like I said, a lot of things could go wrong. Another thing is that this thing is just like, this whole mechanism is really big. The motor would also go up here, so imagine the motor's there as well, and then all the electronics. This whole thing is just kind of big. But the main reason is that it's complex. And when you compare this to my current design, which just uses two omnidirectional wheels, my current design is much, much simpler, so I just ended up going with that one instead. That's all I have for this video. I'd like to hear your guys' feedback on this design, so please leave a comment below if you have any feedback. And if you liked the video, please be sure to hit the like button. If you want to see more, you can subscribe. And that's it. So until next time, thanks.